Hello everyone, welcome back to my channel MatheMagic by Varuna. Now in today's video, we will understand what are parallel lines and what is the distance between two parallel lines. So let us begin. Two lines in a plane are said to be parallel if they do not meet when produced indefinitely in either of the direction. Now what does this mean? For this, let us draw two parallel lines. Say this is the first parallel line, say L. And let's draw another parallel line, say M. Now, if we extend these two lines in both the directions, if we try to extend them in both the directions, like if we try to extend line L in both the directions and line M both the directions or in one of the direction also, in that case what happens is that they will never meet each other. If we see closely, they will never meet each other. Hence L is parallel to M. This is what we infer. Now how do we denote this? L parallel to M, this is a symbol of parallel and we write L is parallel to M. Also, this means that M is parallel to L. It's both the ways. Either you say L is parallel to M or it is M is parallel to L. It means the same thing. So this is what are parallel lines. Now next, let us see the distance between two parallel lines. For this, we will have to draw two parallel lines. Say this is the first parallel line. Let's name it as P. And let's make another parallel line. Say this is Q. Okay. Now, on these two parallel lines, let us take points. Okay, let's take a point on Q first. Let's name it as A and let's take another point on Q, which is say B. Now, what do? We try to make perpendiculars from A to parallel line P and from point B to parallel line to another line to the line P. Now, when we make perpendiculars, it is always straight. It is at a right angle. Okay, so this line is basically at right angle. Okay, and how do we make perpendicular? It's very simple, using a compass. Now, how do? We make a semicircle, then we cut at 60 degree, then 120, and then finally at 90 degrees. So this forms a 90-degree angle. So the line from point A perpendicular to line P, it meets over here at point C. And again a perpendicular from B to line P. Okay, this meets at point D. Also, please understand why am I saying perpendicular? Because if this is 90 degrees, this is also 90 degrees. So the lines are perpendicular. Okay. Now here, let us just write down that AC is perpendicular. Is a perpendicular from A to line P. Similarly, BD is a perpendicular. We write perpendicular like this. Okay, perpendicular from B to line P. Also, this distance, okay, this distance AC and BD, they both are called as perpendicular distances. So AC, it is a perpendicular distance from A to line C, line P, sorry. Similarly, for BD, it is a perpendicular distance from B to line P. Now, What do we have to do? We have to measure the length of AC and we have to measure the length of BD. So we measure the length of both the perpendiculars from one parallel line to the other parallel line. And after measuring through scale, we will get that these two distances are equal. They are equal. Hence, every time if we draw perpendiculars from from any point of one line to the other line, okay, if we draw these perpendiculars, they will always be equal. Hence, what do we infer? That the distance between two parallel lines will always be equal, and this distance is basically what? It is a perpendicular distance. So we get that the perpendicular distance between two parallel lines will always be same. This is what we infer. So whenever we have to identify if two lines are parallel or not, if I have any two lines which are parallel, if we have been given over here, this and this, we will try to find out the perpendicular distance between them. If perpendicular distance between them are equal, then the lines become parallel. Now let us move on to the last part of this, which is the examples of parallel lines. Over here, you can see 4 examples. The first is the railway track. When we see the railway track, here the lines, these are also parallel to each other. Like here, these wooden planks are parallel to each other. Also, when we see these are also here, they do not look parallel, but the railway track is always like this. Okay, the lines will be parallel. Secondly, if we see the second example, which is the zebra crossing also the lines are parallel. The black lines and the white lines are parallel to each other. When we notice the bricks, in the bricks, each face is either rectangular or it is square on one of the side, on two of them. So here the lines, the edges are parallel to each other. It is either here this face is either square or it is rectangle. Here we have made cuboidal bricks. So here cuboidal bricks are the edges are parallel to each other. Now when we see the window pane, again we can we can see that these lines are parallel vertically also and horizontally also, they are parallel to each other. So now these were some of the examples of parallel lines, and that is all for it. And in the next video, we will understand what are parallel segments and what are parallel rays. So stay tuned. Thank you.